Hi everybody. Let's continue with this rasterization business. So let's talk about the general approaches to rasterization. So how do we go about doing this? So one, we can go directly to display. So I have a display, I have a raster, and I program for it. Okay, and again, this is how I started graphics. I wrote my own library. You set a pixel value. You set where to you make a command to draw a circle, a line. That's the most basic everything. So you handle everything. You generate pixels. Okay, so that's a lot of work. Now, obviously, this is my display here. You probably realize that everybody has the same problem. I want to draw a circle. I want to draw a line. I want to draw a square. So if someone was smart enough to do the great job of it and provide some library. So the smarter, let's try fixing that. The smarter way to draw is not to do it yourself. Thanks, Word, Office. The smarter way is to use libraries. You find a library where they've already solved these problems. Common ones you might come across are GDI, Quick Draw. That's a G up there. Or processing. They just solve the problem for you. You say, I want to go over a line from this pixel to that pixel. Fantastic, it solves it. Now that's the direct to display. Now more and more, um, we have a different approach, which uses what's called accelerated or hardware. Okay, this is also known as a GPU. GPU stands for graphics processing unit. These days, you should probably think about a GPU or as an accelerated hardware as a specialized computer that's plugged into your other computer. It has its own memory, it has its own processing, it has its own bus. Everything has its own. So it's kind of like a specialized computer that just has a connection to your main computer, and its job is to do graphic calculations. So this accelerated hardware, this is specialized hardware that quickly and automatically does the calculations. Okay, so this graphics hardware, you want to do all these things. We'll learn a lot of them. Someone's coded it really well with hardware support, made it fast, and then it draws on your raster for you. So cool. So then you learn how to program graphics cards. And again, in the early days, that's what you did. Oh, you have a Rage 3D. Oh, you have this card or that card. Okay, you got to learn that language and learn how to write that card. And every game would actually, like every video game, would have a driver for different video cards built into the game because it was their job to learn how to use the piece of hardware. Now, again, just like with directly to display, people realize this is a lot of work, so along comes libraries where somebody solved the problems for you, wrapped it all up, made it work on different video cards, and they provide them for you to use. The most popular one is perhaps OpenGL, which stands for Open Graphics Library. There's also Direct3D, DirectX, and all those variants. We also have shader languages, and we're not really going to get into those. Shader libraries are programming really deep into the video card and really, I guess they are standard now. But instead of the basics that we're going to be learning in this course, you can do really advanced things with shader languages. And there's things like Coda. You can use your video card to do other mathematics or other operations. It doesn't just need to be graphics. It's a machine, right? That's how it works. So in this class, we're going to be learning the basics of, whoops, we're going to be learning the basics of OpenGL. Let's stop. Let's fix that. Okay. The really cool thing is, just like, when I teach computer science 1010, and, these days it's processing, and before that was Java, and people say, should I really be learning this language? And the answer we give is, well, it doesn't really matter, right? You're learning for loops, you're learning arrays, you're learning the basics, so it doesn't really matter what language you learn in. And I hope you've realized that by now. The same thing goes for graphics. It doesn't matter if we're doing this in OpenGL or Direct3D, or it doesn't really matter. You're learning the basics, and that's what matters. So we're going to be teaching we're going to be using OpenGL, and we're going to be using what's called OpenGL immediate mode. Let me talk about that for a second. There's two main modes of OpenGL. One's called immediate mode, and I'll talk about the other in a second. And we'll be using immediate mode. So the way that immediate mode works is your program sends synchronous commands to the video card. And if you've taken operating systems, that should mean something. But I'll explain it. Our program synchronously sends commands to the, well, I said to the video card, but it's actually to the OpenGL driver, to the OpenGL driver. And then through this to the video card. So synchronous means you need to line up. So I'll go, okay, draw this. The driver wakes up and goes, oh yeah, I got your command. Sure, I got it. I'm going to draw that now. It'll work on it. And then you say, well, let me know when this is ready, and it lets you know. So with synchronous, you say do this, it does it. You say do this, it does it. If you've taken operating systems, you realize that this is very slow, right? See operating systems. You spend a lot of time, I'm sending a command, I need to wait for it to be ready to accept the command. It accepts it, lets me know. You have a lot of back and forth. The processes are waking up and going to sleep. It's very slow. You spend a lot of time waiting for each other. Okay. The code is clumsy. It's like 1990s software engineering. Okay. And you'll see you have to specify everything in order. Specify everything in order. Okay. Do this, do this, do this, do this, hold that, do this, remember that, bring that back. It's clumsy, and it's stateful. Okay, every command you send to the driver, it remembers what state it's in. So if you make a mistake in one function, it's going to impact the rest of your program. Okay, so OpenGL remembers where you left off. So if you set something up in a function and you don't clean it up properly, it's going to impact another function and it gets called somewhere else. That's crazy. That's terrible. It's annoying, right? Challenging across functions. You're going to find something like, it was working, the robot was working, I'm drawing the grass, and suddenly the robot's nose is green. Because something didn't set up or clean up properly. It's stateful. Something over there, the video card driver remembers the state. It impacts things over here. So, really challenging across functions. And to make it worse, this is now considered deprecated. It's bad. We've improved. We have better ways to do it. So I'm hearing you yell, then why on earth are you making us learn it? Well, if you look on the internet, actually, you'll see that a lot of schools do this, and I think it's the right way to do it. It's good for learning. It's good for learning. Okay, you need to learn the basics. This course is, you're learning fundamentals of graphics. You're not learning how to use a library. Once you know the fundamentals, you can pick up any library you want. So this is the best way to learn, in my opinion, that with what we have right now. So remember what we're learning here. You're learning how graphics works, you're learning the math, you're learning the fundamentals. It's going to apply to other things. But we're using an old-fashioned system to do it because it's for educational reasons. So it's good for learning, but if you're doing something in the real world, you want to make sure you use something a little more modern. But use more modern OpenGL in the real world. I can hear some of you now going, this is stupid. I'm wasting my time learning this. Well, you're going to struggle already with graphics probably. If you're curious, go online and look up OpenGL retained mode examples, because the other way to do it is called retained mode. And retained mode, instead of being synchronous, like immediate do it now, you basically set up everything in the driver and push go. So the library, in fact, often your card itself, will keep track of everything. Asynchronously. So you set up everything, you set up your models, you just push go and things work, and you can modify them, push go. So it's actually a better way to do things. But it's really hard to show you a retained mode program, and it's hard for you to understand how it works without learning all the basics first. So after we go through OpenGL immediate mode, by the end of the course, I can show you what retained mode looks like and go, oh, that's the view transform. Oh yeah, I see what's happening here, right? You understand all the pieces. With OpenGL immediate mode, we can jump right in, just like in processing. You just throw a command up and it works. You don't have to do all that overhead. So let's look at your very first OpenGL. Now keep in mind that you're not going to understand everything, but it's actually not that bad. And I'm going to do it in processing, which is really nice because it can bounce off of things that you already know. Okay, so here's our first OpenGL program in processing. Let's see if I can get this to work. There we go. Ta-da! So here's a processing program. Should look familiar. It's really nice. You just jump into processing, and most things you just start going with the commands you're familiar with. Now, when you set the size of your canvas, the new thing here is the P3D. This tells it to use your OpenGL 3D engine. We're not doing 3D right away, but this gives you access to all the OpenGL stuff. So you put P3D as a third parameter for your size of your canvas. And then we have this, which is annoying. This sets the projection to orthographic and gives it the parameters. Now that probably meant nothing to you, and we'll learn that later in the course, but basically you're telling the program what your coordinate system is, and we'll learn about that later in this unit. But that just lets me paint things the way that I want to, and you're done. So this is the only part you have to go, I'm not sure what that means right now, and just toss it up. And then you can start using OpenGL commands. So here's my draw function, and then I have all these OpenGL commands that we're going to learn soon. Reset matrix, rotate, fill, begin shape, vertex, end shape, reset matrix. So I can draw all these OpenGL commands, and it'll do all the 3D work for me. So I click run. Hopefully this works. Yay! We made a program. This is an animated program, which was a little difficult to do with processing, rotating the squares, but we've now done it with OpenGL. So take a look at this program, see if you can figure out what's going on, play with it a bit. You can't hurt anything, right? But this is your very first OpenGL program. Great. So you've seen your first OpenGL program in processing, and I want to show a few more things. The first one is that you can actually, if you're not aware, you can actually do processing right in, that's as big as it goes, right in Java. So you can do all of your homework. If you want to use Eclipse or your favorite Java IDE, you can do that. And I'll provide this file as an example, but basically you extend papplet, you link to the correct libraries, and then you can have your setup function. You have a settings, which is a little different, but then your draw function, and you can use all of your processing and all of your OpenGL right inside a Java program. Bam. So there's actually, if you look at the processing textbook for 1010, There's actually a section on how to use processing in Java. You can look there. I'll put something online here, or you can look at this example. You can actually just do your assignments in Eclipse straight in Java if you want to, using processing. I also want to show you this, but I don't want you submitting this. You can use other non-processing techniques. This is pure Java using JOGL, which is a library, Java OpenGL. And there's a lot more setup as you can imagine. You start setting up event listeners, you add your window, you create a window, you set up your capabilities of your card, you set up your canvas. This is how this is how it used to be. Actually, I did graphics in university in C++, which is even worse again. Um, but then you have your setup here. This is not processing, remember, it's just Java. And there's some timers you can set up. You set up your initialization for your graphics, and then finally you can start to use your OpenGL stuff. Once you get what's called a GL context, which is like the variable that points to the OpenGL for your program, you can start running GL commands, load identity, rotate, color, begin, vertex, and so on and so forth. So this might start to now look familiar with the ones we saw in processing, but the overhead is tremendous. So if you're curious about doing this, if you're doing Java on the side, feel free to look at it and play with it, but let's not use it for our assignments. Okay, so let's take a break there. We'll stop there.